All right, so we're going to be doing digestion. Just bear with me. I'm having to do everything from my phone, and we're on a generator, so I apologize for the amount of noise in the background. And there's a mess in my house because it's been crazy here with no power and trying to cook outside. It's just been nuts. But anyway, bear with me. So we're going to start on chapter 16, and we're actually going to start on slide 4, overview of digestion. This slide just talks about what an alimentary canal or a GI tract is. They're interchangeable terms, and remember the GI tract is from mouth to anus. All right, it's a straight shot. All right, it's a long tube, and I have to think about the way that food enters the tube and leaves the tube, and what happens in between. And that's going to be my GI tract or my alimentary canal. And I usually refer to it as GI tract, but it could be either one, same thing. All right, it does say food must be digested and absorbed, and that's how we get our nutrients. And there's a lot of factors that influence people's absorption in the GI tract. Depends on if they have underlying conditions or if they've had certain surgeries, such as bariatric surgery, weight loss surgery. Those things can mess up the way that you absorb nutrients. But there's a long process of the way that things are taken into our mouth and eventually come out as waste. And that's what this chapter is about. Next slide, we see a good picture. That's a fantastic picture to use as reference. But we're going to talk about all those things over in the next slide, organs of the digestive system. And you can see in table 16.1 that we have got main organs and accessory organs. So we're going to talk a little bit about those. And remember, accessory organs are things that just help that main organ work. All right, so we got our mouth, which is our portal for entry for food. And my accessory organs for my mouth are my teeth and tongue to chomp up the food, and my tongue to help move it around and squish it up, and take those big particles and break them down. My salivary glands, which include the parotid, the submandibular, and the sublingual glands, all those things help produce saliva, so I can help to start breaking that down a little bit inside my mouth, along with my teeth and my tongue. My pharynx is the next stop. The pharynx is the tube that runs from your mouth down, and we talked about that in respiratory. All right, so things enter the pharynx, and then here's where we go different than the respiratory tract. Our epiglottis causes the food to go into our esophagus and not our larynx, and on down into our trachea. And then we have our stomach, and that's where the chemical digestion is. Small intestine, which is broken up into 3 areas, the duodenum, the jejunum, and the ileum. And the accessory organs at that point are the liver, gallbladder, and pancreas. And that slide that we just looked at, go back and look at it in your book. And it shows you how the liver, the pancreas, and the gallbladder are kind of all around your stomach. All right, now, of course, they're not major. They don't actually digest anything, but they give off chemicals to help digestion process. Then we have the large intestine, which includes the cecum, which is the beginning part, and then we have the colon. The colon is broken down into 4 different areas. We have ascending, which is going up from the colon. Remember, ascending means to go up. So up from the colon is ascending. Transverse means to lie sideways. Then we have descending colon, which is coming down. At the very bottom, we have the sigmoid. That is the last stop in the large intestine, or excuse me, the colon. And then we have the rectum and the anal canal, where all the feces eventually come out in the end. It all comes out in the wash. All right. Our next slide is the overview of digestion, and we're going to talk about some words that you need to know. Ingestion is the actually taking food into your mouth to take it into the system. It says complex foods taken into the GI tract, so that means that we're going to take in our vegetables and our meats and our fruits and all that stuff, and then my body's going to use them at other places for the nutrients, but to ingest means to take in. Digestion is a group of processes that break complex nutrients into simpler ones. I have mechanical digestion, which breaks big chunks of food into smaller ones. And that actually kind of starts in your teeth as well. And then we have chemical digestion, where we normally see that actually, and it may even say in this book, that the chemical digestion might start in your saliva. Let me see here. It doesn't really say. We'll talk about that later. But definitely in your stomach as well. We have chemicals that start breaking down food. And then we have a word, motility, and it says a number of GI movements resulting from muscular contraction, which we're going to talk about later. Motility is the rate and the force that the food is moved through the alimentary GI tract. And that's very important for you to remember, because if you have slow motility, then excess water is going to be absorbed from your feces, and then you're going to get constipated. And if your motility is too fast, then your body might not have the opportunity to absorb the nutrients that it needs, and then you'll have diarrhea. So, and we'll talk about that again a little bit later. Your next slide is talking about secretion. And it says secretion is the release of digestive juices and hormones that facilitate digestion. So we could not really break down things any further in our stomach if we didn't have that secretion of digestive juices. And I think, let's see here. It says, this process requires secretion of digestive enzymes and other products into the lumens of the GI tract. After the digestive processes have altered the physical nutrients, they are ready for the process of absorption. And absorption is where my body's alimentary canal or GI tract at different points are going to start absorbing the nutrients through them that I need to survive and live. Your slide says movement of digestive nutrients into the internal environment of the body. And that means that as it goes through the alimentary canal, whatever that piece of food may be, my body's going to take from it what it needs, and it's going to absorb out into my system. Okay, and that's absorption. Regulation. Actually, we skipped a little bit. We forgot elimination. It says part of the digestive system, the large intestine, also serves as an organ of elimination, ridding the body of waste material or feces resulting from digestive process. So, remember when we watched the guys who had to drink their own pee through the life straw? And he said, look, my body said no to this. It used everything that it could. Well, the same thing happens here. My body uses everything that it needs, but there's still waste left over, and solid waste, because we take in things that have a material substance. So whatever we don't need has to come out, and that would be your feces. Regulation. It says regulation of activities such as motility and secretion is required to coordinate the various mechanisms of digestion. And that's all you really kind of get there. And I think we'll probably touch on that later. But your slide says it can come from neural, hormonal, or other mechanisms that regulate digestive activity. So all we're really saying with regulations that there's other things in my body that cause my GI system to work correctly. My brain, my hormones. Those things let me know that those things tell my digestive system to work. Okay? Some people who have had brain damage can't control their bowel movements, or they can't have bowel movements on their own, things of that matter. So there's other parts of our body that control that as well. Your next slide is the primary mechanisms of digestion, and those are just that's a really good table. Table 16.2 is everything that we just went over, a wonderful table to have in your memory, because you'll probably see those questions again. The wall of the digestive tract, it says on page 363 in the new book, and the old book I don't know, I've actually got the new book with me today. It says the digestive tract has been described as a tube that extends from the mouth to the anus. The wall of the digestive tube is fashioned in 4 layers. That is the mucosa, or the mucous membranes. And remember, anything that eventually opens up into the world is covered in mucous membranes, soft and pink and moist. Then we have the submucosa, then the muscularis, which is the muscular part of the digestive tract. That's actually the part that we're going to get that good peristalsis, that motility from. And the serosa. It says the mucosa or mucous membranes, the top varies depending on the GI location. It could be tough and stratified or simple epithelium. Let's see here. Well, if I can find the right place. Okay. It says the mucus of the esophagus, for example, is composed of tough, abrasive, resistant, stratified epithelium. It has to be tough because I'm swallowing foods in there. And sometimes, we don't chew our food good enough. And it's very abrasive to that area and can cause quite a bit of pain. So that area has to be tougher than the rest of it. And then other parts of it can be very delicate and very fragile. The submucosa is the connective tissue layer. You'll find that. Very little on that because it's just kind of the area that has a lot of blood vessels and nerves in it. Okay, so not a lot to say about that one. The muscularis, it says 2 or 3 layers of muscle tissue make up the muscularis. These muscle layers have an important role to play. That is the motility or the peristalsis. Remember when we talk about that wave-like motion that pushes the food on through the canal? And that's because of the muscularis, or the muscles I have. Next on your slide says serosa, but that's kind of skipping a little bit. Let's look at a little bit more about the muscularis. Well, I guess your slide does cover some of that segmentation. All right, peristalsis is the rhythmic wave-like contraction of the gut wall caused by alternating wave-like contraction. So that's this, all right? So there gets a piece of waste or food in here, and then as my muscle will push it forward, and then push it forward, and then push it forward, and that's my peristalsis. It says, in addition to peristaltic contraction that cause materials to move forward, alternating contractions of fibers of the muscularis within a single region or segment of the GI tract also produces a back and forth or swishing type of an intestinal motility called segmentation. As peristaltic movement pushes material down the GI tract, segmentation contractions assist in mixing ingested material with digestive juices and helps continue the mechanical breakdown of larger particles. You will see a picture of that, a very great diagram. Actually, it may be on your slides. Yeah, it is. It's on slide 13. You see peristalsis, and you can see the Now, going back, this is the peristalsis, the wave-like movement. You can see the piece of material that the green piece is, of course, the waste or the food, whatever it is, and the contraction happening behind it of the muscularis and the food moving forward. On 14, you'll see segmentation, where you'll actually have little bits of pieces that move forward and then backwards, and that's causing a churning so that things get broken down more. So forward, then back a little bit, and forward, then back a little bit, and that's just for further breakdown. All right, back up to slide 12 for serosa. The serosa is the outermost covering or coat of the digestive tube. It is composed of a serous membrane, which you may recall from chapter 6. It adheres to internal organs by a visceral layer. So if you have the opportunity, look up on YouTube someone taking out pieces of intestine. They're not just a big free-floating tube. They're attached to a visceral layer or a visceral wall, the inner cavity of your inside of your abdominal cavity. There's actually pieces of tissue that hold it there. So it's not just one big long tube that falls out. It's actually connected in there to your abdominal cavity in some places. In the abdominal cavity, the serous covering is called the visceral peritoneum. A big word to remember. Remember, if it is covering an organ, it's visceral, and it's in your peritoneal cavity. So it is the visceral peritoneum. The peritoneum folds away from the organs posteriorly to form a parietal peritoneum that lines the abdominal wall. Again, so I've got a piece of the viscera, a piece of the pleura, that's lungs, a piece of the serous membrane, if I get myself straight, a piece of the serous membrane that covers the intestine, okay, and that's the visceral peritoneum, and then it comes up on the other side of your abdominal cavity to cover the parietal peritoneum. That's just like the sheet that we had in the lungs. That was the visceral pleura and then the parietal pleura. Okay? Except for here we've got peritoneum because it is in the peritoneal cavity. Let's go on to your next slide 12. It's just a picture that you have in your book about the different layers. You probably should know those layers. They sound pretty important to me. And then, of course, we've got the next slides. We already went over peristalsis and segmentation. You do need to know the difference. All right, mouth, structure of the oral cavity. It says here we've got the roof of the mouth formed by a hard palate. If you stick your finger up inside your mouth, you're going to feel a hard area there. And that is part of your palatine and your maxillary bones. And then a soft palate, if you could feel back a little bit further, it gets soft and it's not as hard, and you can feel an area that you can push in on and you don't feel a bony prominence. And it says this is an arc-shaped muscle separating the mouth from the pharynx. You have the uvula, which is the downward projection of the soft palate, and it looks like a little punching bag in the back of your throat. In your book, it doesn't say much more about it. It says it prevents food and liquid from entering the nasal cavities. A lot of people that happens to anyway. If they have a short uvula, sometimes you'll swallow and it'll go up into your nasal cavities and maybe come out your nose. Then you have the floor of the mouth, which is formed by the tongue and its muscles. You have a papillae, which are small elevations on the mucosa of the tongue. Taste buds are found in many of those little papillae. So you could see those if you look in the mirror. Papillae are always little bumpy projections anywhere in the body. We call those papillae. But if you look at your tongue, you can see all those little bumps on there, and some of those bumps have your taste buds in them. And then we have the lingual frenulum. It's the fold of mucous membranes that helps anchor your tongue to the floor. And that's the thing underneath your tongue. The thing that people have to look at to make sure it's not too close to the tip so you can get your tongue pierced. That is your frenulum. The next slide, 16, is just in the book. It tells you, gives you a little visual of what things look like in the mouth cavity and the tongue. Then we have the teeth. The teeth are the next section. It says we have incisors, which are often called the front teeth. Incisors have a sharp cutting edge when used to bite off or cut food. And we see a big word there called mastication. And mastication just means to chew up food. All right, you need to remember that word though. To masticate is to chew up food. Then we have our canines. Our canine teeth, sometimes called the cuspids, are usually more elongated and pointed in appearance and function to pierce or tear at food. And then we have the teeth referred to as the premolars, are also called the bicuspids, and they're located just posterior to the canine teeth, back behind the pointy ones. They have 2 points called cusps, and that can saw through tough fibrous food, especially when moved forward and backwards against the premolars in the opposing jaw. All right, if you look at the next page, actually, you don't have this slide, but on figure 16.6, you get a good idea of where those teeth are. Now, I don't really need you to know exactly which teeth are where, all right? But do know you can see the deciduous teeth, and deciduous means that they will go away, just like a deciduous tree. Deciduous teeth are what we'll find in young people, in baby or children. And when those deciduous teeth fall out, then we have adult teeth right behind them that comes in. And you can see the difference in the size of the teeth there that comes into